Get ready for IROS 2024, where the brightest minds in intelligent robots and systems are gathering in Abu Dhabi, UAE. This year's theme is Robotics for Sustainable Development. So attendees will explore how cutting-edge robots are helping to make our world a more sustainable place. And IROS TV is here to bring you front row access to the coolest innovations and the latest in intelligent robots and smart machines. Welcome to Abu Dhabi National Exhibition Centre and day 2 of IROS TV 2024. Today we'll be taking a closer look at innovations in robotics. On today's show, we learn how the integration of AI in robotics is transforming the field.
Recently, the emergence of general intelligence method based on foundation model gave more hopes for a better integration of AI for autonomy and decision making.
Take a look at the thrilling challenges of developing AI-powered navigation systems for drone racing and meet some of the competitors in this year's Falcon Monitoring Challenge. Next up, we'll explore robotics designed for extreme environments.
We are now exploring robotics in extreme environment to see how far we can bring those technologies to assist humans.
We also meet with some of the trailblazers shaping the future of robotics.
DKRT's mission is to develop AI technologies that integrate data-driven and knowledge-driven AI to understand the semantics of human life activities.
As you can see, we've got an exciting show lined up. Stay tuned for our very first interview. You're watching IROS TV. Catch all the action as we dive into hot topics, exclusive interviews and lively discussions straight from the heart of the Abu Dhabi National Exhibition Centre. You can find the latest IROS TV episodes airing on the TVs placed throughout the Convention Centre, on the homepage of the IROS conference website and on all of our social media channels. So make sure that you like and subscribe. Joining me now are Jianwei Zhang of the University of Hamburg and Wolfram Burgard of the University of Nuremberg to talk about the use of AI in robotics. Thank you both for joining us. You're doing a keynote this week. AI in robotics is something that you both specialize in, but if I can start with you, how have we seen the integration of AI in robotics in terms of transforming the field?
Integration of artificial intelligence in robotics has been continuous topic for IROS from the beginning. But recently, the emergence of general intelligence method based on foundation model gave more hopes for a better integration of AI for autonomy and decision making.
And Wolfram, how have you seen it change the field in terms of autonomy and decision making? Because there's been some big leaps.
Yeah, I mean, particularly the generative AI has been a major step in the field. So we are seeing right now new functionality that we couldn't realize like a few years ago. So in parts of perception, understanding, and semantics. So we have become way better in interacting with humans, for example. But this is only one part of the story. The other one is also the hardware development side. And we have seen major progress in the past years.
And how else can AI improve the efficiency in terms of industries like healthcare, agriculture? What ways can we see those improvements?
So to create a better learning capability for robotics in the terms of efficiency and adaptability is a very interesting topic currently. For example, in agriculture, and you can let the robot learn during the harvesting and using the audio-visual and tactile information to teach the robot. If you have enough good quality data, and then robot can learn and generate for the skills in the unstructured world.
And Wolfram, what about healthcare? Because that's another area where we're seeing huge advancements.
Wherever we have this interplay between humans and robots, we actually need to have better capabilities of these platforms in terms of understanding what is actually the intent of the user, what is the need of the user. I think there is also some advancement that we can hope getting from these generative AI models, right? So that the robots are basically better able to understand what the specific needs of the patients are.
And in terms of reliability, what are some of the other limitations you can see in terms of AI robotics at the moment or even in the near future?
I think using end-to-end learning, so based on a lot of data, is a promising way to realize the general intelligence, but there are a lot of challenges and how to create a very important vertical application, good data to let the robot learn. Also very important and interesting for the future.
I mean, I completely agree as well. I think that the challenge is where we actually want to bring robots closer to humans. Even you look at automated driving, it's kind of like an automation process. Right? So there's not much interaction with the user. But if you think about a robot in your household, you actually want it also being able to explain what it is doing and why it is doing what it is doing. And then you also want to basically have an interaction with them and explain your thoughts on how things should be done. And the robot should be flexible to that. And that's another challenge where we actually need to put a lot of emphasis on in the near future.
A really insightful conversation. Thank you both for your time.
You're welcome. Thank you.
Our pleasure.
The DKIRT team, part of Japan's IRC, focuses on advancing AI research to foster innovation, safety and industrial competitiveness, while promoting ethical AI use through initiatives like the My at Home Challenge, which involves AI reasoning in spatio-temporal tasks.
My at Home, or MAI at Home, is a groundbreaking embodied AI competition where AI systems face the challenge of reasoning through multi-time spatial-temporal QA tasks in a dynamic, everyday living environment.
Virtual Home 2KG is a cutting-edge technology that generates multimodal spatial-temporal knowledge graphs from a daily activity simulator.
Our mission is to contribute to build a better society through the advancement of AI research in collaboration with industry, academia, and the government.
Fujitsu believes that AI will expand human capability and enrich society, and that we will accelerate research and development that will open up the future of AI.
We warmly invite and encourage anyone interested in pushing the boundaries of AI technologies to participate in this exciting competition.
The Intelligent Micro-Robotics Lab at the Chinese University of Hong Kong, Shenzhen, is pioneering micro-nanorobotics for biomedical applications to develop minimally invasive diagnostic and treatment technologies that revolutionize healthcare through targeted drug delivery, microsurgeries, and early diagnostics.
IML was established to integrate robotics, nanotechnology, and medicine. Our core mission is to develop micro-robots and miniature soft devices for biomedical applications, such as target delivery and minimally invasive surgery. We focus on developing nanorobots in swarms, which are designed for high environmental adaptability and multi-functions. We create biomimetic miniature robots and biocompatible soft devices for early-stage cancer diagnostics. We're also working on building advanced magnetic actuation systems with high precision and large workspaces. IML emphasizes fundamental science and technology developments in microrobotics, while the Center of Micro-nanorobotics at IROS concentrates on applying these advancements to real-world scenarios.
We firmly believe that the incorporation of micro-nanorobotics into healthcare will revolutionize the field. We actively collaborate with medical experts, hospitals, and industry partners to identify the most promising clinical applications for our micro-nanorobotics systems.
I'm joined by Davide Scaramuzza, Professor of Robotics and Perception at the University of Zurich, to talk about drones. Now, we've had some incredible achievements in terms of what your drones can do, AI capabilities, and the agility of them. Tell us more about some of your work.
So I've been working on autonomous navigating drones for 15 years. I started in 2009. We were the first to demonstrate that the drone can navigate and fly all by itself just using an onboard camera and an onboard computer. And this is important because all the commercial drones that were actually navigating up to that point were not truly autonomous. They were mostly flown by expert human pilots or through GPS. We truly wanted to push the limits on autonomous navigation, and we looked around and we realized that actually there is a physical sport where humans actually challenge their skills, and it's drone racing. And so we saw, oh wow, this is truly difficult. So how can we build a machine that one day could defeat the world champion drone racing pilots? So we started working on this 7 years ago. And then in summer 2022, we managed to actually defeat the 2 world champion pilots.
Can you tell us how you were able to do that? Because it's one thing that you can have the AI operated drones, it's another to outperform humans. What was it that made you surpass the capabilities of the humans?
One of the critical issues of a flying machine is its capability to estimate the motion. So a drone should always know where it is with respect to where it started. But the problem is that as you increase the flight speed, the images are blurred, so it's even more difficult for the drone to estimate its own motion. So we have to come up with algorithms to actually kind of let the drone estimate its motion despite the blur. So we built a very accurate, realistic simulator of the drone, of the physics, of the aerodynamics, so that we could actually test the algorithms in this simulator. Another key enabler was machine learning. So the algorithms behind our drone are actually neural networks, which teach the drone to fly very similarly to how kids learn to walk from scratch in the first months of their life. How do kids learn to walk? By making mistakes. And so thanks to this realistic simulation environment, the drones actually make mistakes and they learn new control maneuvers in order to fly close to human pilots, and later even better than human pilots. But you know, they are going to crash hundreds of times. That's why it's more and more important to use simulation.
So how do you see some of these autonomous systems you've been working on influencing real life and real world applications in the future?
Our ambitious goal was eventually to push the limits on research with the hope that the lessons that we will learn in this endeavor will be useful in many other fields. We have another spin-off that is doing agricultural drone, precision farming, estimating the status of crops, spraying pesticides in crops. So we fly drones fast in order to maximize the productivity. We are using the same algorithms that we developed for drone racing. We also have 2 European projects on autonomous inspection of power lines and another on autonomous inspection of container ships. There also the European Union is very interested in letting these drones fly as fast as possible in order to maximize the productivity, because we have 100,000 kilometers of power line in Europe and they need to be inspected regularly, not every 10 years. And so it's important to use swarms of drones to fly fast. And also the same applies to container ships. Often container ships need to go through inspection, but their downtime is like several months. But by using drones that fly fast, we can reduce the downtime to a few weeks or even days. That's all the idea of flying fast.
Wow, really interesting stuff. Thank you so much for your time today.
Thank you.
We're staying in the air and moving from drones to Falcons. We're taking a closer look at the Falcon Monitoring competition. It's where they use computer vision, data and robotics to use non-invasive monitoring systems. It will involve students taking a closer look at first artificial falcons and then the real thing. There'll be teams taking part right here in IROS 24 and as far away as Nigeria.
The idea of the Falcon Monitoring Challenge is to monitor the behavior of the animals while they're in a cage, so that we can understand which ones are active, which ones are eating, which ones are staying still if they have some sickness or something. And we're looking at using from simple cameras and just algorithms to track and find positions, to having depth cameras or even LiDARs to get a full precision scan of everything in the environment. So we have a ground robot that is moving a Falcon through the ground, and we have a flying robot that is going to position the robot in any place and move it around. And the final stage would be with real Falcons moving inside. Right now, what they're using is heavy, so there are some trackers, but they're 200 grams, which are very heavy for a real-life Falcon. And even for the owners, it's also good to have as much information because you can prevent or analyze when they're getting sick, which ones are more active, how are they eating, where are they moving from, and you could even understand why they behave certain ways. So this type of competition and spaces gives us this chance to find real-life applications to solve problems.
I think the main part for us to take part in this competition was the challenge that was there, because as we know, Falcons move very quick, and when you have it in a frame of picture, you need to take multiple samples for you to understand where it's positioning. So it was the challenge mainly that get us interested to participate in it. We are using image processing. It's an AI model. We trained our own AI through the database we received from here. And we are detecting the Falcons in different positions, and we are creating a trajectory of from where it takes off and from where it lands actually. Right now, we are able to detect two birds moving together. But of course, when you have real Falcons, you cannot expect their behavior. So we're training newer models every day to get to that final result in the final stage. I think the main excited point and the main learning thing that you get from a challenge is the difficulties you face. So for example, we can read in books and all of the study material we have in university, but that's in a lab environment. But when you come to a real life and you implement it, you find lots of problems that you never guessed that it will come. Working with the real Falcon will be the reward for us actually here, because we're working towards that. So to have the real Falcon is the most exciting part about the competition.
I'm joined by Usama Khatib, Director of Stanford Robotics Lab, who has focused his research on robotics in extreme environments, including the ocean and space. Thank you so much for joining us.
It's a pleasure, Natalie.
If we can, first of all, talk about some of the challenges those extreme environments we've just mentioned, space and the oceans, present. What are those extreme conditions?
We live in a planet with many challenges, and extreme environments are places where you cannot go. So robotics in the oceans, in space, but also in places where we have disasters, like intervening in Fukushima, or intervening in places where we have radiation, intervening in places where we have fire. All these places requires remote connection because these robots needs the support of human. But at the same time, these robots are going to need autonomy to operate. And this is what is needed, is how to connect human intelligence, intuition to the machine that is working in that environment. So we developed a technique that allows us to control a robot remotely over the internet. And yesterday, we have our device, which is a haptic device, and we were connected through the internet to Seoul, to Singapore, to DLR in Germany, and to Stanford, 4 locations. And remotely, the robots were feeling what we were sending in command, and we were feeling the touch. So we were doing assembly remotely. This is incredible.
So you talked about robot autonomy. Can you tell me how that joins along with the sort of necessity of human-friendly design? Because it sounds great. Does it look great? Is it functional?
We are building robots to do intervention in medical environment, very close to humans. And this has been a major aspect of my research, how to make robots safe. So we started building robots that are mechanically safe, in the sense that we build robots that can be reconfigured for each patient. And whatever happened, a sensor broke, a motor broke, or the computer broke, The robot will never go in the workspace of the human mechanically, it's locked. And when we have another patient, we reconfigure the robot, and now the robot is safe for that patient. So safety is now advancing to a level where we can guarantee 100% that your robot is safe.
And are there any applications outside of these extreme conditions like space or the natural disasters you've mentioned? What kinds of things can we see being done?
So robots can be part of the support for the elderly at home. Robots can be part of the support to workers to reduce the amount of effort. So the worker is guiding the robot and the robot is lifting the weight. So in everyday robotics, we are seeing potentials of robot. But at the same time, we are now exploring robotic in extreme environment to see how far we can bring those technologies to assist human and bring about interventions in environment where humans should not be there or cannot be there.
Thank you so much for joining us in the IROS TV studio.
It has been a pleasure. Thank you.
That's a wrap for our second episode of IROS TV 2024. But don't worry, we'll be back tomorrow with more exciting content. In the meantime, catch the show here at the Convention Centre or online. And don't forget to hit subscribe and follow IROS TV on social media to stay in the loop. See you tomorrow.